find out which are the top 4 teams according to the points table. Now in this case, suppose the next team, which is the 5th team, also has 16 points. Then what will happen? Then we have a tie for selection of 3 teams out of these 4 teams. Then I have to give the next rule of selection, which may be based on net run rate or something else. So my rules has to be very clear, has to be defined, which have to apply on the available data to find the solution. So generally this is the method of doing analysis. First is define the problem, define the requirements. Next is collect appropriate data. It is also called as sample collection, which will solve your problem. Once you have data in place, then you can go for data analysis. You can analyze collected data, and then you can arrive at some conclusion. You can visualize, you can give the representation of your conclusion. So that is a result. Now in case of data collection, we have 4 different methods using which you can collect the data. First is observation method, second is interview method, third is questionnaire method, and fourth is database method. Now, generally, you must be aware of questionnaire method. If I create a questionnaire of all the questions which I want to ask to all the individuals, and then I'll give the possible answers in maybe a 4-point scale, 5-point scale, 6-point scale, whatever scale I'm using. And then I'll just distribute this questionnaire either in hard copy or soft copy through mail. And then I'll collect the data. That is one way of collecting data points, questionnaire method. So generally I should go for questionnaire method when I want to collect data from a large amount of individuals, large number of individuals. Second method is interview method. You can go face to face, have a kind of discussion, and then you can ask questions during your discussion. Then you can note down the data points. That is interview method. So generally you cannot just send the questionnaire to all the upper management people, all the CXOs, all the important people in the company. You should go and visit them personally, meet them, and then collect the data points. So it is based on what type of individuals you are dealing with, and what is the type of the question you are trying to solve, what kind of sensitive data you are handling. You can either go for questionnaire, or you can go for interview, or you can go for a combination of both the methods, questionnaire and interview. Then the third method is observation method. Observation method tells you about just go and sit in the organization, just watch how the movement of data is, what amount of time is taken for a file to go from table 1 to table 2, and all other things. So this is kind of, third method, which is called as observation method. And last is database method. So in database method, you go for past records, last year records, profit and loss statement, maybe financial reports, other audit reports, employee feedback reports. So some reports or some data which is present in database format. So these are the 4 methods using which you can collect data. You can go for either one of them, or you can go as a combination of all 4. So generally, if you're using combination of all 4 methods, then you will collect a very good data which will solve your problem. So this is the complete process of doing analysis. Step number 1 is define your problem. Step number 2 is collect your data. Step number 3, analyze the collected data. And step number 4 is represent your analysis. So in data analysis, as we have discussed, we have 2 branches, statistics and mathematics. Statistics is a probabilistic branch of calculation, and mathematics is a deterministic branch of calculation. So in statistics, we always talk about percentage confidence levels, and in mathematics, we always have to be very clear about whether it is right or wrong, and 1 or 0, true or false. So this is all about the difference between statistics and mathematics as science. Now the next concept is measurement scales or types of data which we can use in analysis. So we have 4 types of data, or we can deal with 4 types of data in the analysis, like nominal, ordinal, interval, and ratio. So in that case, nominal and ordinal are based on counting principle, and interval and ratio are based on measurement principle. So first we'll discuss what is the meaning of counting principle and what is the meaning of measurement principle, and then we'll try to understand the data types also. So if anybody wants to discuss what is the meaning of counting and what is the meaning of measurement and what is the difference between counting and measurement? Yes, anyone? Anyone? Counting and measurement, and what is the difference?
think counting is what we can see individual as object, individual object, and measurement is with reference to one. We go on like differentiate, like some gap is there.
Okay. Okay. Anyone else? Counting and measurement? Okay. I'll give an example to you, and maybe then you can try to give me the difference between counting and measurement. I'll give few statements to you. Statement number one. Uh, I drink coffee every day because I like coffee. I drink coffee every day. Second statement. I drink 3 cups of coffee every day. And third statement. I consume almost 80 grams of sugar per coffee cup. I consume almost 80 grams of sugar per coffee cup, just for example. Now, in which statement I am referring towards counting principle, and in which statement I am referring towards measurement principle? Yes, anyone?
I guess the last one is the measurement principle.
Correct. So when I say I drink 3 cups of coffee, I can count number of cups. So counting is discrete in nature. Counting is discrete in nature. So counting will result, the end result of counting is always a whole number, 1, 2, 3, some number. Number of students. I can have 10 students. I cannot have 10.5 students. It is not possible. I can count number of students. So counting is discrete in nature. But when I say I consume 80 grams of sugar, then it is a continuous process. I cannot count how many particles are there, but I can measure the weight of the sugar which I'm consuming. So it's a continuous property. It can be 80 grams, it can be 80.1 grams, it can be 80.01 grams, it can be 81.5 grams, it can be anything. So it's a continuous process. So we have two principles: counting, which results in discrete numbers, and measurement, which is continuous in nature. So counting is discrete in nature, measurement is continuous in nature. Now, based on this, we have nominal and ordinal, which are the two data types which are based on counting principle. So in case of nominal and ordinal, we can just count the number of occurrences, in short. And when I say interval and ratio, these two data types are based on measurement principle. So apart from counting, we can do multiplication and division also. Okay. So we'll go to that, and we'll now discuss each and every type of data in details. Just for your knowledge, this scheme was developed by Stevens and published in 1946. So all these terms, nominal, ordinal, interval, ratio, are in use from 1946. Now first is nominal. Nominal says values without any inherent order or ranking or sequence. That is the meaning of nominal. So nominal scales are used for labeling variables without any quantitative value. Norm in French is name or label. So I'll explain this with one example. If I'm asking a question, what is your gender? If I'm asking a question, what is your gender? I have two options available, male and female. So just because I have male as the first option and female as the second option, that doesn't mean that males are superior to female. No. And if I put female as first and male as second, that doesn't mean females are superior to male. No. So the location or the order is not important. Male is just a label, female is just a label. So that is what is the meaning of nominal: values without any inherent order. Values without any inherent order or ranking or sequence. That is nominal. We are just talking about labels. Second question: what is your hair color? I am giving options like brown, black, blonde, gray, and other. That doesn't mean that brown color hair are superior. No. Or the probability of having brown color hair is more. No. These are just labels. Though I can give some numbers to them like 1, 2, 3, 4, 5. That doesn't mean this is the order or the sequence of superiority. No. So all these are just labels: black, brown, blonde. So nominal talks about only labels. And that's why I'm giving this statement. Norm in French is a name or label. So we are just mentioning the labels, there is no sequence, there is no ranking, there is no meaning to that sequence. So nominal scales are used for labeling variables without any quantitative value. So there is no quantitative significance to the values. These are just text, just labels. So that is nominal. All of these scales are mutually exclusive, no overlap, and more of them have, none of them have a numerical significance. Now there is a subtype of nominal scale, with only two categories possible. Only two categories possible, or are called as dichotomous nominal variable, like male female. If I have only two categories possible for this nominal scale, then it is called as dichotomous nominal scale. This is called as dichotomous nominal scale, and the remaining two are non-dichotomous nominal scale. Non-dichotomous nominal scale. So this is all about nominal scale. Now we'll go to the next. Next is ordinal. With ordinal scales, it is the order of the values, what is important and significant, but the difference between each one of them is not really known. Ordinal scales are typically measures of non-numeric concepts like satisfaction level, then happiness level, discomfort level, understanding level. So all these kind of things we generally use ordinal scale. I'll explain this with example now. Suppose I'm asking a question, how do you feel today? How do you feel today? My answers are very unhappy, unhappy, okay, happy, very happy. So if you look at the options, I'm starting from negative, I'm going towards positive. So there is a sequence in the, or there is an order in the answers. If I start with positive, I have to end with negative options. So very unhappy, unhappy, I'm going towards positive. Unhappy, okay, I'm going towards positive, and so on. Now, this is okay, that there is some inherent order. So with ordinal scale, it is the order of the values, what is important and significant, that is okay. But the difference between each one is not really known. What is the meaning of this? Meaning of this is I don't know the difference between very unhappy and unhappy. What situation I should call very unhappy and for what situation I should call unhappy. I don't know the difference because it is based on perception. It is subjective. These terms are subjective. Some situation which is very unhappy for me, for somebody else it may be very okay or happy situation. So these are subjective terms. I cannot say definitely that this situation means positive and this situation means negative. No, it is based on perception. So we cannot quantify the difference. We cannot quantify the value of what is the meaning of very unhappy, what is the meaning of unhappy, and then in which situation I should call for what. So that is the meaning of ordinal scale, that the difference between each one of them is not really known. I know the order, okay, but difference is not known. That is ordinal. So ordinal scales are typically measures of non-numeric concepts like satisfaction level, happiness level, discomfort level, and other kind of examples. In above cases, we know that number 4 is better than number 3 or number 2, but we don't know and cannot quantify how much better it is. Difference between okay and unhappy may be or may not be same as a difference between very happy and happy. So that is all about ordinal. So still we are talking about labels. There is no quantitative significance or numerical significance to the values. We are still talking about labels. So both nominal and ordinal. In both measurement scales, we talk about the labels. There is no numerical significance. Only thing is nominal are just labels, ordinal are ordered labels. That's why ordinal is also known as ordered nominal. That is ordered nominal, nothing else. Now, if I ask you that, if I'm asking this question, how do you feel today? For example, if I'm asking this question to 100 individuals, then what max you can do is you can count. You can count how many of 100 have said very unhappy, how many of 100 have said unhappy, how many of 100 have said okay, and so on. And that's why we say that nominal and ordinal are based on counting principle. Only action what we can do is we can count number of occurrences for any specific answer. So both nominal and ordinal are based on counting principle. Fine. Now we'll move to the next measurement scale, which is interval scale. Now interval scales are numeric scales in which we just cannot tell the order, but also we can tell about, or we can speak about the difference between the values. So interval is one step ahead of ordinal. It is also having some order, some logic, some sequence, but it also tells us about the difference or the difference between two values. In case of Celsius temperature, for example, the difference between 60 and 50 is measurable, which is 10 degrees. I can count it. What is the difference between 60 degrees and 50 degrees? Difference is 10. Interval itself means space in between. That is the meaning of interval, which is the important thing to remember. Interval scales tells us about the order and the values in between, and that's why the name is interval. The problem with interval scales. Now, I'll tell the problem of interval. I'll tell how this problem is solved by ratio, and then we'll talk about the difference between interval and ratio. The problem with interval scale is they don't have a true zero. This is very important. They don't have a true zero. This is also called as absolute zero. This is also called as absolute zero, or a true zero, or a true zero, or arbitrary zero, non-arbitrary zero. Fine. So we'll come to that on next slide. What is the meaning of true zero? But the problem of interval scale is they don't have a true zero. And I'll discuss the meaning of true zero on next slide. For example, there is no such thing as no temperature. Without a true zero, it is impossible to compute ratios. So even if I write 0 degrees centigrade, when if I write 0 degrees centigrade, there is some meaning to zero. Zero means something. Zero means nothing. No. Zero means something. Because temperature don't have a defined zero, true zero. And I'll explain that thing on next slide. With interval data, we can add or subtract, but cannot multiply or divide. And because we don't have a true zero, we cannot multiply or divide. But we can add and subtract. We can find out the difference. We can add the difference. That is okay. But we cannot add, multiply and divide. Now, why this is the case with interval? We cannot multiply and divide. And then why we need ratio and all these things. So we'll go ahead now. So the next is ratio. Ratio scales tells us about the order. They tell us the exact value between units, and they also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied. So these variables can be meaningfully added, subtracted, multiplied, and divided. So all operations are possible. So generally, if you have a ratio variable, you can do a lot of things with that variable. Now just look at this example, and then we'll go to the concept of what is the meaning of true zero and why we cannot multiply and divide intervals and why it is possible with ratios. Oil, in this case, price, be it oil price, but price means currency. Currency is ratio type variable. Be it price, profit, loss, all currencies are ratio type of variables because they have a defined zero. $0 is a meaningful number, and zero means zero. Zero means nothing. And the intervals between the values are equal. That is, the difference between $1 and $2 is same as $99 and $100. Even the difference is same. A clear indication of this fact is that you can easily multiply and divide the monetary values. Like for example, the 1 barrel cost is $100, then the 2 barrel cost has to be 2 into X, that is $200. So we can easily multiply and divide also. We can add and subtract also. So all currency are ratio type of variable, because we can add, subtract, multiply, and divide. Why we can add and why we can multiply and divide, and why we say that currency has a true zero, now you'll get that explanation. Yes, can we go ahead? Are you with me, all of you? So what is the meaning of absolute zero or non-arbitrary 0 point or true zero, what we call it as? So consider this example. We have two buildings, building A and building B. So height of building A is 300 meters, and suppose height of B is 600 meters. So this is one example. So now I'll compare this example with the temperature example which we have discussed, because we say temperatures are interval. We cannot multiply and divide temperatures. So we have two cities. City 1 temperature is 20 degrees centigrade. City 2 temperature is 40 degrees centigrade. So now, which one is interval and which one is ratio? We call that temperature is interval. So this example is of interval, and height, we will identify what type of example height is. Now right now, can I say that height of building B is 2 times height of building A? Is 2 times height of building A? Yes, I can say that. Can I say temperature of city 2 is twice temperature of city 1? Yes, right now I can say, based on the available numbers, I can say that. But going ahead, if I convert this meters into centimeters, and if I convert this centigrade into Fahrenheits, can I still say that height of B is 2 times height of building A? Yes. So even if I change the scale, the measurement scale, the ratio remains same. The ratio remains same. But now if I change centigrade to Fahrenheits, now I cannot say the temperature of city 2 is twice as temperature of city 1, because 0 degree centigrade and 0 degree Fahrenheit are different. They don't have a defined 0. 0 degree centigrade and 0 degree Fahrenheit are different. They don't have a defined 0. But when I say 0 meters, it is equal to 0 centimeters, is equal to 0 inches, is equal to 0 kilometers. You take any measurement scale. 0 means 0 in all these scales. So they have a defined 0, and temperature don't have a defined 0. And that is the meaning of, or that is the difference between interval and scale, that in intervals we don't have a defined 0, and in scale, in the ratio, we have a defined 0. So that is all about difference between interval and scale, interval and ratio. And now based on this, this is the kind of summary of all 4 types of data: nominal, ordinal, interval, and ratio. In case of first point, that order of the values is known. Yes, order is known in ordinal, interval, and ratio. Order is not known or is not significant in nominal. We can count. Yes, counting is possible in all 4 types of data. Mean, median, mode we'll cover in tomorrow's session when we'll talk about central tendencies. Can quantify the difference? Yes, difference is possible in interval and ratio. We cannot add and subtract in nominal and ordinal. So that is the same thing, add and subtract. Can multiply and divide? Is only possible for ratio, is not possible for other 3 data types. And why we can multiply and divide? Because they have a true 0. So that is the next point. So this is a kind of summary of all the characteristics of nominal, ordinal, interval, and ratio. Okay. So what I'm doing is I'm trying to collect quality data. I'm talking about quality data. So okay, Divya has joined. Okay, fine. So we are talking about quality data. So we are talking quality of data. There is no numeric significance to data. So we are talking about level of understanding, service quality of operators. So all these are qualitative type of data. So when we say that we have nominal or ordinal kind of measurement scales, we talk about qualitative data. There is no numerical significance to data. So we are talking about qualitative data. And then suppose consider age values of the managers from the nationalized banks in India. So if I go to first branch, and then the age of the branch manager is 42, second is 53, and so on. So this is how much, 5 into 10, 50 observations I have about the age values of the managers of nationalized banks. So what I can do is all these values have some numerical significance. First of all, this is not quality data, this is quantitative data. I'm talking about quantitative data, quantifiable data. Every value is significant, and then I can group together. I can create ranges. I can draw different types of graphs. I can go for Ogive curve. I can go for box plots and everything. So we are going to draw Ogive curve in today's session itself using Excel. So these are the different things which I can do with numbers when we have numbers. So I'm talking about quantifiable data. Every number is significant, like age, height, temperature. So I'm talking about interval and scale measurement scales, interval and ratio type of measurement scales. So when we say nominal and ordinal, I'm talking about qualitative data. When we say interval and ratio, we are talking about quantitative data. So that is a difference between qualitative and quantitative data. Qualitative deals with descriptions, whereas quantitative deals with numbers. Qualitative data can be counted only. Counting is possible. And in case of quantitative, it can be measured also. And some examples have been given, like smell test, appearance, happiness, and all these are examples of qualitative, whereas height, weight, age, length, speed are examples of quantitative. And as we have discussed, that qualitative is based on counting principle and quantitative is based on measurement principle. This is the same thing which I have explained, that when I just say I drink coffee every day, that is a qualitative statement which I am making. But if I am counting number of cups, then it becomes discrete quantitative. And when I am measuring the amount of sugar which I am consuming, then it is a continuous quantitative thing. So data can be either qualitative or quantitative, and quantitative data can either be discrete in nature or can be continuous in nature. Now every object, you take this oil painting as an object, every object will have few qualitative properties and will have some few quantitative properties. It is not like that few objects will have only qualitative and few objects will have only quantitative properties. No, like for example in this oil painting, the kind of texture of brush or what kind of scene it is, what kind of frame the painting has, all these are qualitative properties, whereas the picture size, the weight, surface area and the cost of the painting are the quantitative properties of the oil painting. So it depends on what problem you are trying to solve, what kind of analysis you are doing. It depends on that whether you want to consider qualitative properties of the object or quantitative properties of the object. As we have discussed, the discrete data is counted always. Counting results in discrete data and measurement results in continuous data. And if you want to graphically represent discrete data and continuous data, then bar graph is the graphical representation of discrete data and histograms is the graphical representation of continuous data. In today's session, we are going to draw bar graphs and histograms both on your machine in Excel. Discrete data can only take certain values and there is no gray area in between. So the number of students in a class, you cannot have half student or 7.5 students. It has to be a complete number. The result of rolling two dice can only have values like 2, 3, 4 up to 12. I cannot have 2.5 as a result. In case of continuous data, it can take any value with a range like person's height. It can be in fractions also. Time completion in a race. It can be measured in fraction of seconds also. So when I say continuous data, fractional values are also possible. When I say discrete data, only whole numbers are possible. So the same thing, temperature is continuous, gender is discrete. So type of data, quantitative can be discrete or continuous in nature, and qualitative is just when I'm accepting labels as the answers. So based on all this discussion, what we have finished in today's session is data types, and this chart, like data can be quantitative or qualitative in nature. Quantitative can be discrete or continuous. Discrete can be interval ratio, even continuous can be interval ratio. Qualitative has to be discrete in nature. It can be nominal or ordinal, and in nominal ordinal both things, if we have only two options available, then it becomes dichotomous, otherwise it is non-dichotomous. So these are the measurement scales which are possible in analysis, any kind of analysis. So this is the summary of measurement scales, and here we have finished with the measurement scales also, which is the second part of introduction. So I'll quickly go through the third part of the introduction of this PPT, and then we'll shift on Excel and we'll try to have some graphical representations of data. Some more techniques are available in analysis. I'm just giving the introduction, like time series data. And time series data is a set of data collected over time. Some examples of time series are like stock and share prices taken at regular intervals of time, temperature reading taken at hourly intervals, number of cases of influenza in town on daily intervals. So you can see a trend with time series data. I'm noting down the temperature at different time intervals. So it becomes a time series data that I'm taking temperature after every 2 hours. And from after every 2 hours of temperature data points, I can see a trend of temperature change. So I can say that similar trend may follow on next day also, something like that. So that is how time series data can be used. When I say time series data, we can do two types of analysis in time series. Either we can go for trend analysis or we can go for seasonal variation analysis. So when I say trend analysis, if you look at this graph, the trend is upwards. The trend is upwards. Though there is a fluctuation, sometimes it is going down, sometimes it is going up, but the trend is upwards. So time series data may show continuous upward or downward movement with little fluctuation. And when I say seasonal variation, then if you look at this data, this is data say from 1987 to 1994, but every year, this is 1 year data, this is second year data, this is third year data. In every year, maybe month of November, December, there is a spike. Maybe it is the sales value of woolen clothes, for example. So there is a spike in the sales value of woolen clothes in November and December because we have winter in India. That's why this spike is there. So that is a kind of seasonal variation. So that is also can be analyzed using time series data. So either you can go for trend analysis or you can go for seasonal variation analysis. You can also combine these two, trend and seasonal variation analysis, in one graph, that the trend is upwards, and plus you can see some seasonal variation at maybe in month of every August and September there is a spike in the maybe sales. So you can combine the trend analysis and seasonal variation analysis. Now, just like time series, there are multiple types of different analysis which are present when I talk about data analytics. We are not going to cover all these things. We are just going to cover the basic data models which are based on the concepts like regression and analysis of variance, t-test, or maybe f-test. So all these things like time series, longitudinal studies, and all these things, cross-sectional studies comes under the advanced course. So we are not going to cover all these things. I'm just giving introduction to you in this course. So this is what we have done in this session. This is the schedule, and in today's session we have finished with basic definitions, what and why we need statistics, different data types, qualitative, quantitative, discrete, and continuous. So all these basic things which are required to start the course, we have covered in today's session. Now we'll just shift on Excel and we'll try to complete the graphical representation of data for qualitative data and quantitative data. So I request all of you to start your Excel on your machine, and then I'll tell you to how to install the data analysis tab. It is a plugin actually, how to install that, and then we'll start with a few of the data representations also. So, okay, so now first thing, the most important thing, just go to data section, data tab. Just go to data tab and see if you have this data analysis option available. Data analysis tools for financial and scientific data analysis. Is this option available to you?
No.
Okay, so I'll tell you I'll tell you how to add this plugin. So you have to go to the file section and options. In file section, you have to go to options. Now, based on what version of MS Excel you are using, the location may be some different location. That options location may be something different, but you have to go for options, Excel options. You will get this kind of window, Excel options. Have you got this?
Yes.
Yes, all of you? Yes, Amir?
Just a moment. Yes.
Okay, Divya, Priya?
Yes.
Okay, okay, fine. Nandan, Vandana?
Yes.
Okay. Now, once you have this option, there is one option called as add-ins. Click on add-ins. And by default, in disabled application add-ins, you will find first option as analysis tool pack. Because I have installed, it is in active applications. In your case, it will be in disabled or inactive applications. Just look for inactive application add-ins. You will find first option as analysis tool pack. Just click on that and click on go. Click on analysis tool pack and then click on go. Then you will get this kind of window, add-ins. Just select the first option, analysis tool pack. No need to select other three. Just select the first option, analysis tool pack, and then click on OK. I'll not click because I have already installed. If you click on OK, what you will get is this option in data section, data analysis. Have you got this option? Yes, have you got this option, data analysis?
Yes.
Okay, so once you click on data analysis option, you'll get all the possible methods which we can do in Excel using data analysis tab. So out of all these options, I'll tell you what we are going to cover in this course. We are going to cover ANOVA single factor, ANOVA two factor with replication in last few sessions. Then correlation covariance we are going to cover in session number 4 and 5. Descriptive statistics we are going to cover in tomorrow's session. Then histogram we are going to cover in today's session. Then regression we are going to consider in session number 4. T-test, paired sample, T-test, two sample with equal variance, and T-test, two sample with unequal variance we are going to cover in session number 6. And Z-test we are going to cover in session number 7. So out of all these options, almost 90% options we are going to cover in this course. And this is what max you can do using Excel. This is the kind of analysis you can do using Excel. Fine. So the data sets are with you, and data analysis tab is available to you. So for first few data sets, you don't need data analysis tab. We are just trying to graphically represent this data. So what I'll do is I'll share a few documents also on WhatsApp group. Just download those documents and then we'll start with data representation. Okay. So you must have noticed this data set is from the qualitative document. So we have all these observations. We have almost 50 observations. So how to know that? If you just select all the values in the Excel, you will get this summary at the bottom ribbon. This is the bottom ribbon. In bottom ribbon, you can get the summary count is 50. So we have 50 observations. Likewise, you can get multiple aggregate functions and other functions in the bottom ribbon. So just right click on the bottom ribbon, and then you can select what else you want. Like you want to show minimum, maximum, sum, and other things. So if you can see, I have ticked for average, count, minimum, maximum, and sum, all options. I have ticked for average, count, numerical count, minimum, maximum, and sum, all the options to be displayed in the bottom ribbon. But now Excel has understood that this data is qualitative data, and we cannot calculate average, minimum, maximum for qualitative data. Sum, addition is not possible. So it has just showed me the count value, which is 50, which is getting displayed here, and others are not getting displayed because this is qualitative data. Now we have to create a frequency distribution table for this qualitative data so that we can draw the bar graph and pie charts. So how to go ahead with frequency distribution? So I need to count how many Koch Classic observations are there. So I want to count the frequency of Koch Classic. So either I can go by manual method, 1, 2, 3, kind of, I can start counting the Koch Classic observations, or I can go for a function. So in Excel, if you want a function, if you want to use a function, just type equal to sign, and then you can type any function which is available in Excel. So you have a function called as COUNTIF. In Excel. So type COUNTIF into bracket range. That means the data range. So my data range is all these values. So I'll select all the values as my data range, comma, criteria. That means you want to count for which criteria, for what condition. So what is my condition? I want to count all Koch Classic observations. So my criteria is D3, Koch Classic. Either I can write D3 or I can write into double quotes and Koch Classic. Both ways it is possible. Koch Classic ending double quotes. Or directly I can write D3. So 19. That means Koch Classic is present for 19 times. Instead of Koch Classic.
So just one doubt.
Yeah.
So how you got this classes? Like, did you use any function or manually you just put there?
No, manually I have put there. For qualitative, you don't have any option in Excel. For quantitative, I'll show you on further like histogram and everything, how to create classes. But for qualitative,
So
you
remove duplicates we can use?
Yes, you can use that. You can use that.
Okay.
Yes.
Thank you.
Okay, so COUNTIF, and then the criteria is Koch Classic. Otherwise, you can directly give the D3. You'll get the same output, 19. Now, I want to do the same thing for remaining cells. So if I just copy and if I paste it here, what is happening is, if you look at the first formula, the range is B2 to B51. B2 to B51. When I copy and paste in the next cell, because I am advancing to next cell, automatically it will advance the cells in the formula part also. It is going to B3 to B52. So I want to keep B2 to B51 as the fixed part, constant. I don't want to change that because my data range is not going to change. So part of the formula which you don't want to change, you have to put $sign there. You have to put $sign there. So I'll write $B, $2 and $B, $51. That means don't change B and 2. That is the starting cell of my data, and don't change B and 51, which is the ending cell of my data. Keep it fixed. Even if I copy this formula and paste it somewhere else, this part of the formula will remain constant. Okay. Now I'll just copy this and then I'll paste it in the remaining cells. And what I'm getting is the frequency distribution table automatically. You can see automatically D3 has become D4, D4 has become D5, D6 and D7. But the first part has remained constant. And that is how you can use the autofill option in Excel. And this becomes my frequency distribution table. Yes, any doubts? Have you done the same thing on your Excel?
Yes.
Okay, now it is very easy how to draw bar graph and pie chart. You must be aware of all these things, but just at part of the process and course, I'll just show you. So I'll go to, I'll just select the data, all the headings and all the frequencies. Go to insert chart option, simple chart, and you'll get the bar graph. Simple thing. Similarly, if you want to draw a pie chart, again select the data with labels, go to insert, pie chart, simple pie chart, and you will get the pie chart. So these are very simple options. You must be aware of this, how to draw bar graph and how to draw pie charts. So this is how you can deal with qualitative data. So what max you can do with qualitative data is, you can go for a frequency distribution table, you can go for a bar graph, or you can go for a pie chart. That is what max you can do with qualitative data. Is it clear? Okay, so I will start with the remaining part of today's session. So now I am dealing with quantitative data. As you can see, every number is significant. So I need to create groups out of this data. I need to create a group data out of this. Like I want to create class intervals like 10 to 15, 15 to 20, something like that. Now how I can decide what class intervals I should have? Once you select the data, you will get minimum and maximum values, 12 and 33. That means you should have class intervals which will cover your minimum value and which will cover your maximum value. So maybe I'll go for class intervals like 10, 15, 20, 25, 30 and 35. So in Excel, I call them as beans. In Excel, I call them as beans. So you have to give all your bean lengths. So 10, 15, 20, 25, 30, 35. These becomes my bin lengths. These becomes my bin lengths. Now next step, how to create class intervals and then how to create histogram out of it. So I'll cover both the things so that you can implement the same thing for these two problems as practice. Okay, so go to data, select data analysis and select histogram option. Select the histogram option. Click on OK. Once you select the histogram option, it will ask for input range and bin range. So input range, yes, we have this input range, including label, select everything, input range. And bin range, yes, we have defined the bin range. So this is my bin range, including label. Labels, I'll take on this option because my first row in both the input range and bin range, my first row contains labels. So I'll click on this. If you are not selecting this cell, then don't click on labels. Output range, what happened? I'll just go back. Yeah, output range, suppose I want to start my output from say this location. And what I want is only chart output because I don't want anything else. I just want a histogram, so chart output. So after all this, just click on OK. And what you have got is histogram and the bin range. And yes, so if you look at this output, then this bin talks about all the values which are less than 10. Then this bin is about 10 to 15. So you can say the lower limit is 10 and the upper limit is 15. Then this is group 15 to 20. This is 20 to 25. This is 25 to 30, and this is 30 to 35. So you get this grouped data because of this option automatically ready-made. So you can just create a group data, interval data out of this list of data values. Now look at the histogram. We say that histogram is continuous. We say histogram is continuous. So we want to make this graph continuous first of all. So just click on any of the bars. Just click on any of the bars. Right click, format data series. Right click and format data series. Once you'll right click and format data series, you'll get one option called as gap width. You'll get option as gap width. Just make it 0. Gap width, make it 0%. And you'll get the histogram. So this is the histogram for this table. So this normal quantitative data, we have converted that data into a group data, and we have drawn the histogram for that data also. Yes. So if you look at this output, then this bin talks about all the values which are less than 10. Then this bin is about 10 to 15. So you can say the lower limit is 10 and the upper limit is 15. Then this is group 15 to 20. This is 20 to 25. This is 25 to 30, and this is 30 to 35. So you get this grouped data because of this option automatically ready-made. So you can just create a group data, interval data out of this list of data values. Now look at the histogram. We say that histogram is continuous. We say histogram is continuous. So we want to make this graph continuous first of all. So just click on any of the bars. Just click on any of the bars. Right click, format data series. Right click and format data series. Once you right click and format data series, you'll get one option called as gap width. You'll get option as gap width. Just make it 0. Gap width, make it 0%. And you'll get the histogram. So this is the histogram for this table. So this normal quantitative data, we have converted that data into a group data, and we have drawn the histogram for that data also. Where on x-axis we have the bin values, and on y-axis we have the frequency values. So this is how you can draw the histogram in Excel. So you have to define your bins carefully, and then you can draw the histogram. So this is one part, how to draw histogram. Is it clear to you, all of you? Yes. Can we go ahead?
So can you just repeat the initial process, like the bin and the calculation?
Yes.
Initial, the frequencies, how you got?
Yes. I'll do it everything again. So I'll just delete this. Okay. So I have to just define the bin values first of all. Looking at my data set, this is my data set. If I select all the values, I get the minimum and maximum value. Minimum is 12, maximum is 33. That means my bins should be such which will cover my minimum and maximum values from my data set. So if minimum is 12, my bin should start from 10. And if maximum is 33, my bin can end at 35. And between 10 to 35, then if I want to have equal size bins, then I'll define bins as 10, 15, 20, 25, 30, and 35. So this is my data input and this is my bin input. Once this is ready, go to data section, data analysis, histogram, select the histogram option from the available options, click on OK. Input range, select the input range with label. Output range, bin range, select the bin range with label. Click on labels because my first row in both the tables have labels. So I'll click on labels. Output range, suppose I want to start my output from this location and I want only chart output for histogram. So I'll not select anything else. I'll just select chart output. I'll click on OK. So I'll get this chart output, histogram, and this is the bin output or the frequency distribution table. Now, if you look at the first row, this indicates the values which are below 10. We have 0. There are 0 values which are below 10. There are 6 values which are in between 10 to 15. Then there are 7 values which are between 15 to 20 and so on. So what I'll do is I'll just put the formula and then I'll drag it till the last cell. So this becomes my frequency distribution table. This becomes my frequency distribution table for this data set. Well, this is my lower limit, this is my upper limit, and these are my frequency values. So this becomes my frequency distribution table for this data. And this is my histogram. So I'll just select the histogram and click on any of the bars. It will by default select all the bars. Right click and select format data series. And in format data series, you'll find one option, gap width, make it 0. Make it 0. So you'll get this histogram. So this is how you can convert your quantitative data into a frequency distribution table, and then you can draw a histogram of that frequency distribution table. So now you can do the similar thing, same thing for remaining 2 histogram data sets, which we'll discuss in tomorrow's session. This is a straightforward salary data. I don't think you'll find any problem with this salary data. If you look at the data, the minimum is 8 and maximum is 49. So your bin can have have the starting point as 0 and ending point as 50, 0 to 50. Either you can go for bin size of 5 or bin size of 10. It depends on you. Create the frequency distribution table and draw the histogram. Second problem, this histogram problem is a bit tricky problem. You try to solve on your own, and then I'll tell you a few things like outliers and concepts of outliers, how to identify outliers, and then how to sanitize the data and everything. That we'll do in tomorrow's session. Now for this bar graph and Ogive curve also we'll cover in tomorrow's session. It's almost 10:15 now. So we'll stop today. So this sheet and remaining 2 problems of histogram and scatter diagram we'll cover in tomorrow's session, and then we'll start with central tendency tomorrow. So that's it from my side for the first session. See you tomorrow at 8 AM IST. Thank you.
Thank you.
Thank you.